Hi students, this session will introduce the superposition theorem for AC circuits. And in the previous session, we have discussed about the superposition theorem for DC circuits. And the steps for doing or steps for solving the circuits with this is the same as we had discussed before. And the only difference is that here, instead of using resistive elements, we are using inductive or capacitive elements. So we use the term reactances or impedances. Okay. So what is superposition theorem for AC circuits? Superposition theorem states that the response in any element in a circuit is the vector sum of the responses that can be expected to follow if each source acts independently of other sources. As each source is considered, all of the other sources are replaced by their internal impedances, that is voltage sources are short circuited and current sources are open circuited, and this theorem is valid only for linear network. In a network containing complex impedances, all the quantities must be treated as complex numbers. So in the case of superposition, you can write the same definition as we have discussed in the case of DC network. You can write the same statement for the superposition theorem, but here instead of taking the resistive element, we are using impedances. Okay, and here the steps are similar, that we at a time we are considering the effect of one source only, and other sources will either be short circuited or either or open circuited. If there is more than one voltage sources, then one voltage source will be short circuited, and if there is a current source and we are considering this effect of one voltage source, and that current source will be open circuited. So consider the circuit containing two sources, and one is voltage source V angle 0 and other is the current source IA angle 0, that you can see in this diagram, and the impedances used in the circuits are Z1, Z2 and Z3, and here the current through Z2 is marked as I, and we are interested in finding the current through Z2. So for finding the current I, and the first step is that, what will be the first step? You have to consider one source alone. Okay, so first find the current I due to the voltage source V alone, and here the current source IA angle 0 degree is open circuited. You know that current source should be open circuited when we are considering about voltage source. So the circuit diagram can be drawn as V angle 0, Z1 and Z2 will be there, Z3 also there, but there is no current source, so that part will be open circuited. And here we can see that the equation for current can be obtained from the simple Ohms law. You can see that this circuit will be, the closed path will be containing two impedances Z1 and Z2 and the voltage source V. So the equation for current I1 will be equal to V angle 0 divided by Z1 plus Z2, and in this case Z3 will not be considered because it is a part of an open circuit. So there will be no current flowing through the Z3. So we are not considering the effect of Z3. Okay. So that is equation 1. And next, this is the circuit diagram. And next, in the next step, we have to find out the effect of current sources. And so we are considering the current source alone. In that case, we will short circuit the voltage sources. So in the second step, for finding the current I through the Z2, we will consider the current source, and here the voltage source will be short circuited, and the circuit diagram is shown in the figure. And in the circuit diagram, the current is marked as I2, that is the current through Z2 due to the effect of current source alone will be I2, and we can find out the current through Z2 by using current division rule. You can see that there are two parallel branches Z1 and Z2, and the current I2 will be flowing through Z2, and there will be a current source IA. So you can apply current division rule in order to find out the current through Z2. So I2 will be equal to IA angle 0 into Z1 divided by Z1 plus Z2. You can see that. See, I2 will be the current through Z2, that will be equal to IA, total current into impedance of the other parallel branch, that is Z1 divided by total impedance of the parallel branch, that is Z1 plus Z2. So I2 will be equal to Ia angle 0 into Z1 divided by Z1 plus Z2. That is the second equation. Then the current passing through the impedance Z2 will be equal to, that is current passing through the net effect of current passing through the Z2 will be equal to the current due to voltage source and current due to current source. So we can write it as I will be equal to I1 plus I2. So we can do a first problem. Determine the voltage across 2 plus 5j ohm impedance by using superposition theorem. So there is a voltage source that is 50 angle 0 and impedances are, there is an inductance and its reactance is J4 ohm. There is a series combination of resistor and inductor and its reactance is 2 plus 5j, and there is a capacitor, its reactance is minus 3j ohm, and the current source value will be 20 angle 30 degree. Okay, so this is a circuit containing AC sources. So you want to find out the current through 2 plus 5j ohm. You can see that it is in the middle part. So first of all we will consider the voltage source alone. So current source will be open circuited. So the circuit diagram will look like this. See, this is a circuit diagram that is given in the question, and we can first draw the impedance circuit. For that we are using this representation, that is 50 angle 0, and the reactance or impedance of inductance will be 4j, and similarly resistor inductor combination will give the reactance of 2 plus 5j, and the capacitance will give a reactance of minus 3j, and there is a current source that is an AC current source. So it is represented like this. And in the first step we will consider the effect of 50 angle 0 voltage source alone, so that current source will be open circuited. So minus 3j part will not be there because it is open circuited. So we can draw the diagram like this. Okay, so we want to find out the current through the 2 plus 5j ohm, and that is denoted by the letter I1. So I1 will be obtained by the Ohms law, that is I1 will be equal to 50 angle 0 divided by 4j plus 2 plus 5j, that is equal to, current will be equal to voltage divided by total impedance. So here the impedance, total impedance is 4j plus 2 plus 5j, that is equal to 2 plus 9j. So we can do the calculations, and you can do either by converting 2 plus 9j into polar form. Once there is a division process, then it is easier for you to convert it into polar form, then you can easily divide it. Okay, see, 50 angle 0 divided by 9.22 angle 77.47 degree is there. So 50 divided by 9.22 will give you 5.42, and 0 degree divided by 77.47 will give you minus 77.47. So if there is a division of polar terms, then the magnitude terms will be divided and the angle terms will be subtracted. So you got the value of I1 is 5.42 angle minus 77.47 ampere, and that is due to the effect of the voltage source alone. So that is the current, and you are asked to find out the voltage across 2 plus 5j ohm due to the current I1. So how can you find out the voltage across 2 plus 5j ohm? See, you got the value of current, then you can easily calculate the voltage by using the Ohms law, such that Ohms law states that voltage will be equal to current into resistance. So you got the value of current as 5.42 angle minus 77.47, and it will be multiplied with the resistance, here the impedance value, that is 2 plus 5j. So in order to make the calculation easier, you can convert 2 plus 5j in terms of polar form. So you can convert it by using the calculator. So 2 plus 5j will give you 5.38 angle 68.19 degree. And once two polar forms come, you can multiply the magnitude terms of each polar form, and angle terms can be added if the operation is multiplication. So you will get V1 will be equal to 29.16 angle minus 9.28. So that is, you can denote it as equation 1, because you are asked to find out the voltage across 2 plus 5j ohm. Now you find out the voltage value due to the voltage source alone. Next step, you have to consider the current source alone. So in the next step, you will consider, this is the diagram given in the question, and in the next step you have to consider the effect of current source alone, so that voltage sources will be short circuited. So the resultant circuit will look like this, that is shown in the lower portion. So there will be current source, and you can represent the other impedances, and you can find out the current through the 2 plus 5j as I2, and you can see that this is a parallel circuit, and you can apply current divider rule in order to find out the current through 2 plus 5j ohm. So I2 will be equal to total current 20 angle 30 into 4j divided by 4j plus 2 plus 5j. So that will be giving you 20 angle 30 into 4j divided by 2 plus 9j. In order to make the calculation easier, it is better to convert it into polar form. 4j will give the polar form 4 angle 90, and 2 plus 9j will give the polar form 9.22 angle 77.47 degree. It is better to use calculator in order to, for the conversion, because it will save the time. So you can see that in the numerator side there are two polar terms. So the operation is multiplication. So magnitude terms will be multiplied and angle terms will be added. So after the operation in the numerator, you can do the division with the denominator, and again in the numerator side and denominator side there is polar terms. So magnitude terms will be divided and angle terms will be subtracted. So you got the value of I2 as 8.68 angle 42.53 degree. That is second equation. So you got two values, I1 and I2. You can see that both the currents are flowing through 2 plus 5j, and in order to find the voltage across 2 plus 5j, you can use Ohms law. So voltage across 2 plus 5j will be equal to current into impedance, current into impedance. So V2 will be equal to current is 8.68 angle 42.53 and impedance is 2 plus 5j. So you can make the calculation by converting it into polar form, and you will get the value of V2 as 46.69, that is angle 110.72. That is equation number 2. Sorry, I said that I2 will be equation number 2, not V2 will be the equation number 2. So you got two values, V1 and V2, and you are asked to find out the voltage across 2 plus 5j. You can see that in both the cases current flowing in the downward direction. So the total voltage will be the addition of V1 and V2. So you can find that voltage across 2 plus 5j ohm due to both sources is V equal to V1 plus V2, and the addition or subtraction is determined by the flow of the current. See, in the second case I2 is flowing to downwards. Similarly in the first case I1 is flowing downwards. So the voltage drop has the same sign. So you can add both this. Okay, V1 plus V2 will be give the total voltage. So both are in the polar form. So you can write it as 29.16 angle minus 9.28 degree plus 46.69 angle 110.72 degree. Here the operation is addition. So it is better to convert it into rectangular form. So the rectangular form can be obtained by the use of calculator. So we will get the rectangular form as 28.78 minus 4.7j plus minus 16.52 plus 43.67j. So total voltage will be equal to 12.26 plus 38.97j. And in polar notation it can be 40.85 angle 72.53 degree. So voltage across 2 plus 5j ohm is 40.85 angle 72.53 degree. So based on the need, you can convert the rectangular form into polar form or polar form into rectangular form. It purely depends on the type of operation. Suppose if there is a division operation is going on, then it is better to convert it into polar form. Then you can simply add the angle terms or subtract the terms based on the multiplication or division operation. And if it is an addition process taking place, then it is better to convert the polar form into rectangular form. That is why I used the conversion from polar form to rectangular form here. So you got the value of voltage. So voltage across 2 plus 5j is equal to 40.85 angle 72.53 degree. This is all about this section. Okay.